Hello, my name is Suresh Sitaraman. I'm a professor in the George W. Woodruff School of Mechanical Engineering. My primary research area is computer-aided engineering and design. I also work in micro and nano engineering, manufacturing, and mechanics of materials. In our lab, we study micro and nanoscale structures used in microelectronics and other devices used in a number of applications: automotive, aerospace, medical, telecommunication, and computers. Unlike any other industry, microelectronics industry has gone through dramatic changes. They have continuously increased in performance. They have continuously decreased in size. At the same time, the price has continuously come down. In computing devices, for example, the number of transistors on a chip has gone from few million transistors to hundreds of millions of transistors to more than 1 billion transistors on a single chip. The electronic devices which are used in automotive underhood applications, aerospace applications, go through extreme temperatures. So because of these reasons, with shrinking in the size, with higher temperature, higher performance conditions, these things could easily fail. Our lab develops and uses computational and experimental techniques and methods to study various failure modes in microelectronic devices. For example, we use magnetic actuation and other techniques to measure interfacial fracture parameters for materials used in microelectronic applications. We are also fabricating and calibrating nanoscale and microscale strain sensors which can be placed on microchips. We are developing compliant interconnects which can mechanically decouple the die from the substrate and therefore can reduce stresses in the die. We use electroplated copper nanowires for electrical as well as thermal applications. And we use various clean room facilities on campus to do fabrication. Reliability of these devices is extremely important. Studying and understanding the reliability means we need to model and test these structures at microscale and nanoscale. And that's why we are studying these structures at these small scales so that we can understand how these devices will perform in the real life, in the operation as they are used. Before joining Georgia Tech in 1995, I was with the IBM Corporation. I was always attracted to the academic work, the ability to choose your own research, the freedom to pursue different research avenues and publish, the opportunity to work with and mentor students, the continued exchange and interaction in the classroom are some of the appeals for me in this profession. So in addition to doctoral, master's, and undergraduate students, we also have high school interns working in our lab. And this experience has been extremely helpful to the high school students to understand what engineering is all about. And several have chosen to pursue engineering based on their internship experience in our lab. Woodruff School is a great place to work for several reasons. For example, we have world-class faculty members who work on cutting-edge research. For a university, our facilities and infrastructure are one of the best in the world. Our size is large. That means for every research topic that you want to collaborate or pursue, you have one or more faculty members doing research in that area. In spite of our ranking and accomplishments, our faculty members and staff are down to earth, approachable, and friendly. If you have a research question or course-related question, you can walk into any one of the faculty members' office or staff members, and they are willing to help you. Clearly, this is a great place to work and great place to pursue your education.